G'day team, welcome back to another video, and today we're going to sort of extend on solving trig equations using algebra. We did a little bit of a few videos back, but we're going to make it a little bit trickier and just add a few more things in. So let's have a look at a few examples just to get the ball rolling. Now these are some examples we have seen before, so I just want to do them as a bit of a refresher. So what we want to do when we have an equation like this, we want to isolate the cosine x, or in this case the sine x. So we do that just by doing algebra. So we've got -3, so we add 3 to both sides. Cos squared x equals 3. Divide by 4 on both sides. And then we've also got to take the square root of both sides. So we've got cosine of x is equal to plus or minus, really important, √3, and then the square root of 4 is just 2. So I've got cos x equals plus or minus √3 on 2. Now, the whole idea of this topic is to identify what x gives me a cosine of plus or minus √3 on 2 in the domain 0 to 2 pi. Now, hopefully you know that 0 to 2 pi is our unit circle domain. So hopefully you've got your unit circle with you. We're going to go through. So all we have to write is x. So we're finding the angle and we're looking on our unit circle for angles that give a cosine or an x coordinate of √3 on 2 plus or minus. So I've got pi on 6. I've got 5 pi on 6. I've got 7 pi on 6. And I've got 11 pi on 6. Now, all 4 of these angles will give me plus or minus √3 on 2 in our unit circle. So then let's jump to the next example. Now, the big key difference here is there is a 2x here. So what that means is we need to do the same thing to our domain as we've done to our argument. So we've doubled it here. So we need to double our domain. So we're actually looking for 2x, but we're looking between 0, 2x, and 4 pi. So that means we have to do 2 rotations of our unit circle. So what 2x's give me a sine of √3 on 2 from 0 to 4 pi? So sine is our y coordinate, so I've got pi on 3, 2 pi on 3. Now that's the only 2 between 0 and 2 pi, but we've got to do one more rotation. So all I do is add 1 rotation to my current answers, so that is 2 pi plus 2 pi. And now we're going to go through simplify and solve for x. So I've got pi on 3, 2 pi on 3. Now pi on 3 plus 2 pi on 3 is 7 pi on 3. And then 2 pi on 3 is 8 pi on 3. But we've got 2x on the left-hand side. We want x, so we divide by 2 on both sides, and that's just times in the denominator by 2. And as you can see, there's a few that will simplify a little bit. So we've got pi on 6, pi on 3, 7 pi on 6, and 4 pi on 3. So they are my angles that make that true. Now, that should all be pretty familiar to you, but let's have a look at a slightly different example. So solve exactly for x in 0 to 4 pi. But you can see my argument has changed in a slightly different way. Instead of timesing or dividing my x, I'm actually adding something. Now, just like we did before with our domain up here, how we times everything by 2, we're going to add pi on 2 to both of these here. So my new domain is actually 0 plus pi on 2 plus pi on 2 in here. And then I've got 4 pi plus pi on 2, which is 9 pi on 2. So you can see how our domain has actually changed quite differently and makes it a bit more complex than our previous question. So again, we're going to look at what sign values give me positive √3 on 2 from pi on 2 to 9 pi on 2. So pi on 2 we keep going. So our first answer, so we've got x plus pi on 2 is equal to 2 pi on 3. That's my first one in our domain. Now we go around, we've got pi on 3 plus 2 pi. We've got 2 pi on 3 plus 2 pi. And then we've also got pi on 3 plus 4 pi. Now, all of these should be within our domain. So let's tidy them up and just double check. And if we've gone too far, we can just drop one off. So I've got 2 pi on 3. Pi on 3 plus 2 pi, as we said up here, was 7 pi on 3. This one is 8 pi on 3. And then pi on 3 plus 4 pi is 9 pi on 3. But what we want to do now is solve for x. So we actually want to be taking away pi on 2 from all of these values. So x equals 2 pi on 3, take pi on 2. 7 pi on 3, take pi on 2. And 8 pi on 3, take pi on 2. And we've also got 9 pi on 3, take pi on 2. Now these can be some tricky fractions, so what we're going to do, we're going to grab out our graphics calculator, and we've got 2/3 of pi, take 1/2 of pi, gives me pi on 6. We've got 7 pi on 3, take that is 11 pi on 6. Change the 7 to an 8. We got 13 pi on 6, and then finally we've got 9 pi on 3, which is 5 pi on 2. And that they are my x values. So you can see they are a little bit trickier, but the same strategy applies. Hopefully this helps, and we'll see you in the next video. Thanks.